All right, for independent and dependent probability. All right. Independent means separated from each other, have nothing to do with each other. What I do on the first one has nothing to do with what happens with the second one. For example, if I were to flip a coin and then roll a die, does it matter if I get heads or tails on the first one? Is that going to affect what happens when I roll that dice the second time? No. Has nothing to do with it. That would be independent. All right, if you remember back before spring break, we said and means what? When it was or, what did we do to find the answer? We added. If it said or, we added the stuff up. If it says and, we're going to multiply. So when it says and, we're going to multiply the fractions. All right? Now, dependent means whatever happens the first time is going to affect what happens the second time. So, for example, if I'm doing the, let's do the cards. Say I'm doing the cards and I say, what is the probability of picking?
Kyle Cooper, Jacob Fuller, please report 622.
All right, if I had the cards and I said I'm going to pick a club and then another club, but when I take the first one out, I'm not going to replace it. All right? That's going to change things. All right. So what happens the first time is going to affect what happens the second time. And when we get to the problems, it'll make a little bit more sense. All right, this bottom one down here, this last part, when it has that little line in between them, it says the probability of B given that A occurred. In other words, A's already happened, so now what's the probability of B happening if I know that A already happened? And again, it'll make more sense when we start doing the problems. All right, here's some examples of independent. Get those down so we can know what we're talking about. All right, so all of these would be examples of independent. If you toss a coin and then roll the dice, what I do when I toss a coin is not going to affect rolling that dice at all. All right, choosing a card, replacing it, and then choosing another card from the deck. Again, the replacing part is what's important, and we'll get to that when we get to the dependent stuff. When it says replacing, that makes it independent. Landing on heads from two different coins. If I flip a coin over here and a coin over here, the first one doesn't affect the second one. Rolling a 4, then rolling a 3. Again, doesn't. What happens first time does not affect the second time. And picking a red marble, replacing it, and picking a green marble. All right, all of those would be examples of independent because the first one does not affect the second one in any way. All right, so if I'm looking at dependent things, like picking a marble, not replacing it, picking another marble from the same bag, picking a king from the deck of cards, not replacing it, picking a queen, picking a letter from the alphabet, not replacing it, picking another letter. When you start doing this, the not replacing stuff, what happens on the first one affects what happens on the second one. Therefore, it's going to be dependent because it's depending on what happens first as to what happens second. All right, any problems there? All right, tell me what those are. All right, first one says picking two people out of a crowd and see if they are both fans of the local sports team. That should be independent. Why? Because whatever this guy picks has nothing to do with whatever this other person picks. The first person's choice has nothing to do with the second person's choice. So that would be independent. Picking a book from a shelf, not replacing, and picking another book from the same shelf. That's dependent. When I do the not replacing stuff, that's dependent. Picking a 7 from a deck of cards, replacing it, then picking a 9. That's independent because picking a 7 is not going to affect picking the 9. And I replaced it, which means the deck was the same the second time as it was the first time. Picking 2 cards from a deck and both are kings. That one is dependent. Why? No. Because when I pick 2 cards, when I pick the first one and then pick the second one behind it, did I replace it? So this one didn't say not replacing, but you've got to understand that it's not replacing. So I didn't replace it when I picked the second one. So when I pick 2 in a row like that, that's not replacing. Not replacing means dependent. All right, copy this down. Show you what we got to do. All right, we said if we see and, what does that and tell me? Multiply. I'm going to be multiplying something. Well, first of all, when it says replaced, what does that mean? Independent. First thing has nothing to do with the second thing. So that means when I pick a red the first time and a green the second time, has nothing to do with each other. Well, what is the probability of getting a red the first time?
3/16.
Really, this is what I'm doing. I'm going to say probability of red times the probability of green. Well, probability of red was what did y'all say?
3/16.
3/16 times green is 5/16. Type it in the calculator, get your answer, and you're done. That should be what, 15/256? Alright, yellow and blue. So that means I'm going to do probability of yellow first times probability of blue in second. So yellow in this case would be what?
2/16.
2/16 times blue, which is 6/16. Now you can simplify these if you want. First, I would just go ahead and type them in the calculator and it'll simplify it for you at the end. How much is this?
12/256.
2/what?
12. Oh, wait, you want this?
I want the simplified version. 3/64. All right, see what you can do with those bottom two down there. All right, probability of blue and green. So I'm going to do probability of blue first, multiply by the probability of green second. So blue would be what, y'all say?
6/16.
6/16 times green, which is 5/16.
15.
How much?
15/128.
All right, green and yellow. I will do green times that by the yellow. So green would be 5/16. Yellow would be 2/16.
5/128.
If I had a third one in there, everybody got these so I can erase it? I'll tell you what, I'll just erase it. Suppose we had probability of red and green and blue. How would I do that one? What's probability of red? 3/16 times the probability of green times the probability of blue. So you would just type all of them in, multiply them all out. Y'all gonna have to tell me what that one is. So if I do this, I would get 45/2048. All you're doing is typing them in, multiply them out, you got your answer. So independent should be pretty easy. All right, are there any questions or problems with that right there? All right, you should be able to do this one right here, remembering the cards. All right, so for these, when I'm looking at the deck of cards, I know 7 and 9, picking a 7 has nothing to do with picking a 9. So I'm going to do the probability of 7 first times the probability of 9 second. Well, 4/52 times 4/52, and that equals 1/169. All right, red and odd. Well, probability of a red would be what? 26/52 there. Odd. 5/26? Yeah, just go straight to the simplified version. All right, club and a number less than 7. So I'm going to do each one of those by itself. There's 13 clubs over 52. There's 24 that are less than 7. All right, probability of not a 5, so I'm gonna do that first. Times probability of a king, so that's 48 out of 52. And then 4 out of 52 there. And then the last one is probability of a black 4 times the probability of a 3, so black 4. Let me write that better. Right, black 4 is 2 out of 52, and then 4 threes.
1 over 338.
1 over 338.